Okay, so this is the question from section 8.6 number 12. As you can see here, there are three parts. The sine integral function, this is the sine integral function. We denote this function using six, which is the function of x. And we would like to complete part A through C. So first of all, let's look at the complete picture of the function f of t. This is defined only for t is not equal to 0. When t is 0, this function value is 1. So that's the one thing you have to keep in mind. And then first question is, this is the fact we have given the value, the function to the power 4, the absolute value of the function to the power 4 is less or equal to 1 on this interval. Then we would like to find out upper bound for the error for the Simon's rule. So if you check your what is that, notes, class note, no, it's the book. So here is the error formula. This is the error upper bound, where m is go back here, m is 1. It's the bound for the function, and b is pi over 2, a is 0, n is 4. So that's the information we have given. We need to calculate this value. And how do you do that? You can use calculator or anything else, whatever machine you have. M is 1 for us, b is pi over 2. So I'm going to use parenthesis pi over 2 minus a is 0 in our case, because it's about this a0, b is pi over 2. M is this bound, this upper bound for the function here, and n is 4. So what is that? Pi over 2 minus 0 to the power 5 power 5, and divide this number by 180 and divide that by n to the power 4. In our case, n is 4 to the power 4. So when we do this, we are going to get this number, which is it's e to the power negative 6. So that means after you have to divide this by 1 million. So by doing that, your value is 0.000207. So that's what I'm going to put here. It's a 0.000207, because we need to round it to the 5 decimal. It would be 21. Okay. So now estimate the value of this function by using Simpson's rule. It's not Simon, sorry, I was mispronouncing this name here. Simpson rule. So first of all, we need to know what is Simpson rule. So let's go here in your textbook and find out the definition for the Simpson rule. This is just the approximation technique given by this rule. So to calculate the approximation technique, you need to calculate this value. What is this value? Del x can be found by using this formula. Remember, b is upper integration limit, a is lower integration limit. In our case, it's a is 0, b is pi over 2, n is 4. By using that, we can find out the del x. And then y0. So what happens is, let me, where is that? Okay, where is that? So we need to calculate this value. How we can calculate this? First of all, we need to find out del x. Del x is b minus a over n. In our case, it's a pi over 2 minus 0 over 4, which is eventually pi over 8. So we would like to divide this interval from 0 to pi over 2 into 4 different subinterval, 1, 2, 3, and 4. So the first one would be pi over 8. Second one would be pi over 8 plus pi over 8, which is pi over 4. Third one, it would be just add pi over 8 each time. and then what is that, 3 pi over 8, and then eventually if you add pi over 8 here, it would give you pi over 2. Okay, so 1 2 3 4 sub interval. So we would like to find out this value here, this one, that's called Simpson's rule to approximate the integration. And then y0 means the value of the function at x0. x0 is, as you can see here, this is x0, this is x1, this is x2, this is x3, and this is x4. So y0 means it's the function we have given in this particular problem is sine t over t, sine t over t. So y0 is sine 0 over 0, but remember, for this particular function, whatever we're using, the value of the function is 1 when t is 0. So by using that fact, we can say, hey, y0 is 1. Okay, and then what is y1? y1 is value of sine x1 over x1. x1 means this value, pi over 8. y2 is sine x2 over x2, which is pi over 4. Okay, and keep doing like that. y3 is sine 3 pi over 8 over 3 pi over 8, and then finally y4 is sine pi over 2 divided by pi over 2. So we need to calculate all this value, and eventually, as you can see here, you need to add y0 plus 4y1 plus 2y2 plus 4y3 and keep going, but the very last one would be nothing, it's just yn. So by using that fact, because it's a lot of calculation, so I use Excel sheet. So starting from 0, this is my x0, this is x1, this is x2, this is x3, this is x4, this is y0, this is y1. As you can see here, it's a sine this value, like here, sine x1 over x1, sine x1 over x1, sine x2 over x2, sine x3 over x3, keep going like that. Eventually, we need to add the first one plus 4 times second one. Look at here, 4 times second one plus 2 times third one plus 4 times fifth one. Keep going up to last point where you don't times it by any number, by using exactly this formula. You can see here, keep going. Each time the first one last would be without multiplying by anything else. In the middle, it's a 4 times and 2 times and 4 times and 2 times. You have to just keep multiplying by these numbers. Eventually you need to multiply this sum by del x divided by 3. In our case, del x is, as you can see here, it's a pi over 8, and when you divide that by 3, that will be pi over 24. So I need to multiply this by pi over 24. So when I do that, it gives me 1.37. So that's what I'm going to plug here. It's a 1.37. If you round it to the 5 decimal place, it's a 1.370. What else? 79. That's the 5 decimal place. Exactly using that rule, Simpson rule, we can calculate the value. And then finally, this error out of this estimation, what's the percentage? So to calculate the percentage, you just have to divide the error, which is 0.00021, by this number and multiply it by 100. That gives you the percentage, and this is 0.01532 percentage. If you want to round it to the 3 decimal place, it's a 0.015. So how do you find the percentage? Just divide this number by this number and times it by 100. That gives you the percentage. Okay.